Okay, so we are going to have a look at genetic crosses just to get an understanding of what they look like and what information we get from them. So for the people that weren't in the room the day we made babies with socks, here's what we did. We had a mum sock. So a mum had two pairs of socks, apologies. One sock was white and the other sock had stripes. We had a dad that had the exact same two socks. So one that was white and one that had stripes. And they put their socks under the table and their offspring picked some socks. If you happened to get two stripy socks, you ended up being a child that had a condition called sickle cell anemia. What this means is your red blood cells, instead of being these biconcave shapes, are actually sickle shaped and they get caught in your capillaries. You're tired, lack of energy and pain. In very serious cases, they can lead to stroke. So it isn't a very nice condition. So if the offspring, as we say, got a stripy sock each from mum and dad, they would have the disease. So they would have sickle cell anemia. If they got a white sock and a stripy sock, they would be normal, but they would be what we call a carrier of the gene. And finally, if the offspring were lucky enough to get white socks, two white socks, they would be normal. So that was where we started with those three things. And I'm going to bring you over here to this part down on our bottom left now. So in terms of variation in you, that exercise with the socks should show you the variation in you comes from the genes you got from your parents. So dad's sperm, mum's egg, all those genes come together and they make you. And your chromosomes are important because they carry your genes. So your genes are just instructions for hair, for livers, for enzymes, for all sorts of things. So if you are a geneticist, they instead of using socks, they use letters. So we have down here this statement: green big G is dominant to yellow small g. So what does that mean? There are three combinations of letters that you can get. You can get a big G, you can get a big G, and you can get a small g. And remember, each one of these, this is going to be maybe the dad's gene, and I don't have pink, but this would be the mom's gene. So you're getting each one of these from mom and dad. And if you're here, then this is going to be completely different to the other two. So in this instance, for this example, it's probably a plant. That plant would be yellow because it got two small g's. Similarly here, this plant is going to be green because if this big G is present, this dominant gene is present, it stops the recessive, the small letter, from working. So while we call this green, technically it's also a carrier of yellow. You're just not seeing the yellow in this parent. And then finally, if you get two big G's, this is going to be a green plant, and they're not going to be carriers of the yellow. So that's what happens with geneticists in the real world. They apply letters to them, and they do a thing over here, which you can see, which is called a Punnett square. So when we have this type of scenarios, what we're trying to see is, in this scenario here, we have the alleles for black coat, big B is dominant to the alleles for grey. So the first thing I would do here is that I would write out my three letters. So we know this one is going to be grey. We know that this one is going to be black, and this is black, and technically it's a carrier for grey. So we're going to make some babies, and to do that we need to know these are like the socks. So there's two socks here and two socks here. But in this one on the right hand side, all of the socks are going to be the same. So they're all small b. Whereas here, we're going to get a big B and a small b. So in lesson, we did a little thing called a Punnett square. It's like the multiplication tables you might have used in primary school, where we divide it up like this. So these are these two letters, these two socks, and this here is the one sock that that parent has. And now we do our cross. We go big B, and we go small b, small b. So then what does those offspring look like? So we know now big B, small b is going to be black, and we know small b is going to be grey. So now we're ready to fill in our table. So our offspring, in this instance, the babies that we make, are going to look exactly like the parent. One of them is going to be black, and the other one is going to be grey. The other type of question that they can give you is up here, this thing called a pedigree chart. Now, pedigree chart just shows you how individuals are related to each other. So it's like a genetic history. So usually for dogs, for horses, they have pedigree charts and you can see who their parents are. Similarly now for cattle, because we do loads of IVF on cattle, there's pedigrees. So you know if you're putting sperm into a particular heifer, that you know who the dad is and who his parents were, and back and back and back. So if the line joins across like so up here, then these parents have meant that they've had a baby together. When the line drops down then, here, these are the children. And sometimes you have to look at the children to figure out what is the genetics of the parent. So in a pedigree, a square represents a male. If it's darkened, he has hemophilia, and if it's clear, he has normal blood clotting. So how many males are there? So we're looking for squares. So we have 1, 2, 3, 4, 5, 6, 7, 8 males. How many males have hemophilia? So they are the clear squares. So if we're looking then for clear squares, we are looking for 1, 2, 3, 4, 5. So we have 5 hemophiliacs. Now, the circle is female. If it's darkened, she has hemophilia. If it's open, she is normal. So in terms of our circles, we have 1, 2, 3, 4, 5, 6, 7. We also have 8 circles. And in terms of hemophilia then, so we're looking again for the clear. No, we're looking for the dark, apologies. So we have 1, 2. So 2 females have hemophilia. So we've said the marriage is the horizontal line, or having the babies. So how many babies or connections are there? So we are now looking for, here's a connection, here's a connection, here's a connection. So there have been 3 pieces that have babies. So the first couple in row 1, they have had 2 children, because there's only 1 drop down line coming for them. So these have had 2 children, and one of which has had babies with someone else. And the couple in row 3 over here had quite a lot of children. They have 1, 2, 3, 4, 5, 6, 7. Okay, so I hope that's given you an understanding of the genetic crosses.